Hello, I am Taylor Brown, and this is Lab 6, and right now I'm on exercise 1, which is just a NMOS MOSFET in series with a resistor. And then we have two sources here. We have one across the NMOS, and then we have a second fixed voltage of 5 volts. And then the voltage across my MOSFET, I'm going to be changing the voltage of it by 0.5 volts from 0 to 5 volts, and then measuring the current coming from the NMOS at each of those voltages. And so far I've measured at 0 and 0.5 volts, and both of them are giving me a reading of 0 milliamps. And the simulated was 41 nanoamps. All right, now I'm just adjusting one of my power supplies increasing it by 0.5. So I've already done the 2 and the 2.5, and for the 2.5 input voltage, I'm getting a drain current of 18.92 milliamps, and my simulated was 24.99 milliamps. All right, now looking at an input of 3 volts, I'm getting a drain current of 48.83 milliamps, and my simulated was 44.688 milliamps. For 3.5 volts, I'm getting 49.75 milliamps, and I simulated 46.08 milliamps. For 4 volts, I'm getting 50.07 milliamps, and I simulated 46.7087 milliamps. For 4.5 volts, I'm getting a drain current of 50.24 milliamps, and I simulated 47 milliamps. For a 5 volt input, I'm getting a drain current of 50.34 milliamps, and I simulated 47.3 milliamps. All right, now I'm on exercise 2, and I've created the circuit here on my breadboard, and I have a fixed voltage of 5, and then for my input voltage, when it's 0, the LED should be off, and then now when I change it to 5, the LED is on. All right, now for the case where the LED is on, I'm supplying 5 volts, and I am measuring the drain current by breaking the circuit between the drain leg and the LED, and I'm getting a reading of 2.64 milliamps. All right, now I'm measuring the voltage across my resistor when the LED is on, and I'm getting a voltage of 3.141 volts. And now this is my voltage across my LED. I'm getting a reading of 1.897 volts. All right, now we're gonna be looking at exercise 3, where we have this NPN BJT in our circuit. So I have constructed this circuit on my breadboard right here. This first leg right here is the collector node, and it's getting 5 volts. It's getting 5 volts supplied from there. And then there's the base leg, which is supposed to be connected to a resistor, and then the resistor to my varying voltage source, which is shown just right here. And then the emitter leg is to ground. So the emitter leg is right there, and I have it connected to ground. So now I'm just gonna be slowly incrementing the varying voltage over here from 0.2 to 0.8 volts. And to start off, I have 0.2 volts, and I'm getting a base current. I've broken the circuit right here. I'm getting a base current of 0 microamps. And up until 0.6 volts, all of the amperages should be very small, so I should be getting 0 for most of those. For a VN of 0.3 volts, I'm also getting a reading of 0 amps. All right, for a VN of 0.4 volts, I'm getting a base current of still 0 amps. For a VN of 0.5 volts, I'm still getting a reading of 0 microamps. All right, now for my VN of 0.6 volts, I'm getting a reading of 1.8 microamps, and my simulated was 1.6 microamps. Now for my VN of 0.7 volts, I'm getting a base current reading of 28 microamps, and my simulated was 26.6919 microamps. All right, now for my VN of 0.8 volts, I'm getting a base current of 92 or 91.9 microamps, and my simulated was 91.5374 microamps. All right, now we're going to be looking at exercise 4, where we have the same NPN BJT in our circuit, and I've constructed this circuit onto my breadboard right here. So I have my collector leg connected to a 1 kilo ohm resistor, which is then connected to my fixed 5 volts. And then my base leg is connected to this resistor, which is connected to my variable voltage input. So right now it's at 0. And then I have my emitter leg connected to ground. So first, I'm going to be starting with looking at when the VN is 0. So when this voltage right here is 0. So I have it set to 5 and 0. And I'm getting a voltage reading of 5.055 volts. And my simulated was 5 volts. Alright, now when my VN to my base leg is 1 volt, I'm getting a voltage of 76.2 millivolts. And my simulated was 75.47 millivolts. Alright, now for a VN of 2 volts, I'm getting a voltage reading of 31.5 millivolts, and my simulated was 39.1829 millivolts. Alright, and now when my VN is 3 volts, I'm getting a reading of 20.5 millivolts, and my simulated was 29.38 millivolts. When my VN is 4 volts, I'm getting a voltage reading of 16.6 millivolts, and my simulated was 24.7 millivolts. And now, when my VN is 5 volts, I'm getting a reading of 14.5 millivolts, and my simulated was 22 millivolts. Alright, and now I'm just going back and doing the VCEs for the negative VNs. So now I'm supplying negative 1.5 volts to my circuit. I've just done this by flipping the polarity of my clips, and I'm getting a VCE measurement of 5.054 volts, and my simulated was 5 volts. Alright, and now finally I am supplying a VN of negative 2 volts to my circuit, and I'm getting a VCE reading of 5.054 volts, and my simulated was 5. So with that, I've completed exercise 4. Alright, so now I'm technically supplying a VN of negative 2 volts because I'm using this to supply 2 volts, and then I have just switched the polarity of these 2 prongs here. So I have the ground here and then the 2 volts here. So when I do that, my IC is giving me a reading of 0, and my simulated was very small. It was 18 picoamps. And now for my VN being negative 1.5 volts, I'm getting a current reading still of 0 microamps, but this is because whenever the VN is negative, the current readings are very small. I still have 17 picoamps, and so this is kind of limited on how precise the measurements can be. Alright, now I'm still on exercise 4 and I have the same circuit, but now I'm just measuring the IC, the current out of the collector. So when my VN is 0, I'm getting a reading of 0 microamps. And this is because my simulated value was super small. It was 17 picoamps. Now when the VN is 1 volt, I'm getting a reading of 5.04 milliamps, and my simulated value was 4.92 milliamps. And now when my VN is 2 volts, I'm getting an IC of 5.09 milliamps, and my simulated was 4.96 milliamps. And now when my VN is 3 volts, I'm getting an IC reading of 5.10 milliamps, and my simulated was 4.97 milliamps. And now when my VN is 4 volts, I'm getting an IC of 5.11 milliamps, and my simulated was 4.97 milliamps.
Nobody's worried
And
about
now
this 'cause it's
finally
not
when
used for
my
it.
VN is 5 volts, I'm getting an IC reading of 5.11 milliamps, and my simulated was 4.97 milliamps.